Okay, our next topic is going to be switch port analyzer, along with a remote version of this feature, which can be used, well, in our case, those two features can be used to deploy IPS in a promiscuous mode. Because as I said at some point previously, there are actually two types of deployment for IPS. We can enable it in the promiscuous mode and in the inline mode, where the promiscuous mode means that IDS is going to be getting copy of the real traffic. So it is not going to be analyzing the real packets, but just a copy of the traffic. And for this to work, we have to somehow divert the copy the traffic and send it to the IDS for inspection. And this is going to be the method that we will be using, SPAN or RSPAN. There are two other methods, such as to use a vampire tab or a VLAN access list. But in our case, this is going to be SPAN or RSPAN, which you will be using to copy the traffic. Now, the difference between SPAN and RSPAN is in the amount of switches involved in the configuration. Because with SPAN, our session source and destination is going to be connected to the same physical switch. So we will have just one switch that we will be dealing with, such as GET1. Now the session source, this is what we want to copy. This can be a physical port or just physical ports, or maybe entire VLAN or multiple VLANs. So we will have our hosts connected over here, host 1, host 2, and they are part of VLAN, let's say 10. So we can say that we want to copy the traffic that you received in VLAN 10, or maybe from those two individual ports. Just an example. So this is going to be our session source. Now, session destination is where we have our IDS connected. So we simply say that we want to copy the packets from those two interfaces or the entire VLAN and send it to this port, let's say FO10, and IDS is connected to FO10, so it is going to get those packets. Single switch, session source is connected to the same device as the session destination. Now with RSPAN, we will be dealing with multiple switches. And the advantage of this option is that your session source can be on other switches than the session destination. Like with just 3 devices interconnected with trunks, CAT1, CAT2, and CAT3 as a sample topology. IDS is connected to this FO5 on CAT3. So this is going to be our session destination versus my session source can be somewhere here, maybe over here as well. I want to copy the packets from those ports, or maybe just from the entire VLAN. Like in the previous case, let's say that this is VLAN 10. So I would have to configure those two switches. Say that this interface or the entire VLAN is my session source. We would have to do the same over here. This is my session source. And then destination on those devices would be the RSPAN VLAN. So with RSPAN VLAN, there is one additional VLAN that you need to create, which is used to carry those copied packets. So RSPAN VLAN, you have to create it. You have to specify that this VLAN is a special type of remote span. This is a VLAN attribute. And you want to make sure that this VLAN is allowed on the trunks between your sources and the destination. So allowed on the trunks. And obviously on the switches you would say that this is your session source, so the ports where we have connected our clients. Destination would be then our RSPAN VLAN. So this would be session destination on Cat 1 and Cat 2 versus on Cat 3 you would say that the session source is the RSPAN VLAN, where obviously the destination is our IDS. So in the previous case, it was not needed to create any type of additional VLANs because the devices are connected physically to the same switch. But in the second case, we need to somehow carry those copied packets between the switches, and this is why we need to use that RSPAN VLAN. Okay, the syntax for the commands is shown on the slide. For the destination part of the session, there are two options that you will be able to use on the Cisco switches. This is ingress VLAN option and the encapsulation replicate. So if we focus on this first keyword, ingress VLAN, the purpose of this option is to allow the packets to be received on our session destination port. And this is going to hold true for both types of SPAN deployments, regular SPAN and remote SPAN. So in this case, FO10 is our destination, which normally means that that the switch is never going to expect any traffic to be received on this port. Like if IDS sends a reset packet, so it wants to reset a session because the signature fired, which is configured with a reset action, it wants to terminate the session to protect the victim. This packet is generated by the IDS by its sensing port, and since the packet is received on this interface that is connected as session destination, SPAN or RSPAN, the switch by default is going to drop the packet. So when you configure that ingress VLAN option, in the destination as one of the keywords in the monitor session destination command, you can specify a VLAN number where the traffic received on the destination port will be sent to. So in our case, we would go for VLAN 10, which would mean that when the reset is sent by IDS, the switch gets the reset and is going to send it to that VLAN 10. Versus this second command, the encapsulation replicate is useful when we want to deploy our interfaces in the so-called VLAN group mode. Now, with the default configuration of SPAN or RSPAN session, the traffic that is being copied to the IDS is untagged. So even if you, for example, even if you were to configure your switches to say that you want to monitor a trunk link, like let's say that this is going to be an example of a SPAN session, we will have two switches, CAT1 and CAT2, connected with a track. And this is, let's say, FO1 on CAT2. This is a track link. And IDS is connected over here. So you can technically say that you want to monitor a track. This would be our session source. And this would be our destination. Now, even that you're monitoring a track, which means that you will be you will be seeing tagged packets with a tag value. You will be still sending by default traffic without a tag. So the encapsulation replicate command can be used to modify this, to change this behavior, and tell the switch that you want to include the tag value. So then if you configure the command and you see the packets in VLAN 10 and VLAN 20, you will be sending the traffic along with the tags. And this information can be then used on our IDS to differentiate between the packets from different VLANs. Okay, and a sample configuration here for SPAN and RSPAN sessions. So actually this was the example for SPAN, just one monitor session source and destination, the same switch, single physical box, versus with RSPAN. Example with two switches, one is going to be our session source and a destination. So as I said, the key thing to remember here is that the RSPAN VLAN must exist and it must be known by all switches in the path between the session source and destination, so that the spanning tree instance is end-to-end for this VLAN. And second, the tracks between the sources and destinations must definitely allow this VLAN. So this is because otherwise this is going to break the spanning tree instance and also the RSPAN configuration. So once the remote span VLAN is configured and, for example, propagated to all of the switches using BTP, you can now configure your sessions. So this is going to be that session source on the first switch. You can, as I said, monitor a single physical port, maybe multiple interfaces, VLAN, multiple VLANs. You also have an option to specify what direction of the packet flow you want to look at. Do I want to copy packets that I receive on the switch port? Do I want to copy the packets that I sent out the switch port? Or maybe I want to copy packets seen in both directions. And then on this first switch, destination is going to be the remote span VLAN. This is going to be then our source on the other switch. And then destination on the second switch is obviously IDS. Possibly those two options can be also enabled, or maybe just one of them, depending on what you're trying to accomplish.